right. So yesterday we took a look at exponential functions and their graphs. We talked about domain and range. We talked about transformations, determining if they're growth, decay. And then at the end, we took a look at some word problems. You put money in an account, it grows, this and that. Today, we're going to solve exponential equations. So I have a little chart here that I made that you don't have to, but I strongly suggest you making your own little chart just like this to have handy with you, because what we're going to be doing when we solve these exponential equations, we're going to have to find the same base, and the same base is the big number. And so we're going to be using different numbers in here to help us convert, for example, to help us convert the number 9 to just 3 squared, or converting the number 256 to 4 to the fourth power. So we're going to be having big numbers like big bases and things like that, and we're going to have to convert those to a smaller base so that something can cancel out and we'll just have a regular equation to solve. So again, I strongly suggest you making your own little chart very similar to this so that you can have, so that when you're doing your conversions and changing your numbers in or out, you'll have everything in one convenient spot. After you do a whole bunch of these, then of course you won't need your chart anymore, but just starting out, it might be very helpful for you to have a chart. So we're going to go ahead and jump into some equations. So when you're solving these exponential equations or inequalities, the first couple of steps are going to be different, but then it's going to turn into something that we already know how to do, which is solving equations. So solving equations comes up a lot. So let's jump down here to number 1 and number 2. Okay. So the first one that I gave you a problem that already has the same base. Got a base of 3 here. I have a base of 3 here. When you have the same base, your bases cancel out. So that cancels and that cancels. Once your bases cancel out, you're left with a regular equation. 2x minus 1 equals x plus 2. We go through and solve this equation, subtract x from both sides, add 1 to both sides, and just like that, we got x equals 3. So when you have the same base, both 3s, both 7s, both 10s, whatever the base may be, when you have the same base, your bases cancel and life is easy. You just solve the equation. All right, let's jump to, of course, this case won't come up a lot. The rest of the problems that we do will have different bases. So let me walk you through how to do those. I have a base of 2 here, and I got a base of 4 here. Okay, base of 2 and a base of 4. Your goal is to try to change the bigger number to the smaller base. So the problems that we're doing today, we will be able to change the bases to the same number, but sometimes the bases cannot be the same numbers, and I'll show you how to do that sometime next week. So let's try to make this 4 be a base of 2. So let's change 4 to a base of 2. If I come up here, the reason why I like this chart here, I see the number 4. I see that we can change 4 to 2 squared. So we're going to make a substitution and make 4 be 2 squared. So the left-hand side is going to stay the same. 4 is going to be 2 squared, and then x plus 2. So notice my exponents stay the same. I just changed 4 to 2 squared. Now from here, the bases cancel. 3x equals, we do the distributive property, 2 times x is 2x, and 2 times 2 is 4. We go through, solve the equation, subtract 2x from both sides, we get x equals 4. So the only new piece for today is to change our bases to be the same. All right, next problem, number 3. Now, I did give you a fraction on purpose. Sometimes people get intimidated by fractions. This is 3 to the 2x minus 1 power. Step 1, let's get this out of fraction form. So we're going to keep this. When you change something out of a fraction form, you get a negative exponent. So if you think way back, probably was in Math 1, when you talked about properties of exponents, you can change it and make it a negative 1 for your exponent. So that means that this is going to be 3 to the 2x minus 1 and 9 to the negative first power. Now I can change both of these numbers to be a base of 3. So I can keep this. And I can change 9 to be 3 squared, because 9 is 3 squared. And let's not forget our exponent. Our bases cancel out, cancel, cancel. 2x minus 1. 2 times negative 1 is negative 2. We'll go through, solve the equation, add 1 to both sides, and divide. We get negative 1/2. And that's our answer. All right, let's take a look at what happens if we need to change both bases, which is highly possible. Nothing's wrong with that. I have 4 over here, and we have 8 over here. We need to change both of these to be the same base. So this is a 4 and this is the 8. I need to change it to be the same base. So if you go look at your chart, we want to see if somewhere in the set of numbers that we have here, if we have a 4 and an 8 that's listed, because if we have a 4 and an 8 that's listed, that means we can change it to the same base. So here's where I have 4 and 8. So 4, I can change to 2 squared, and 8, I can change to 2 to the third. So those are the substitutions that we're going to make. I'm going to make 4 be 2 squared, and I'm going to make 8 be 2 to the third. So 4 became 2 squared, and 8 became 2 to the third. From here, your bases cancel out. Make sure you do the distributive property. 2 times x is 2x. 2 times 1 is 2. 3 times 2x is 6x. And 3 times 3 is 9. Make sure you do the distributive property. From here, we're in our bag. Go through, solve your equation. I'm not going to do that right here, but for this one, you should get negative 7/4. Subtract 2x, subtract 9, and divide. You should get negative 7/4. So I'm not going to solve the equation part in this video because we know how to solve equations, but I will at least set up the problem so that you will have some examples on how to do the same base. All right, I got some more on the back side that we're going to do. Again, I'll set you up. Make sure you understand this concept of finding the same base. Then I'm just going to say ... opposite operations, solve your equation. All right, here's another fraction. Let's change this to negative 1 exponent. So properties of exponent. So 1 over 16, I can make this 16 to the negative first power. Now I need to make these be the same base. Sometimes students get confused and they want to do like, well, 8 times 2 gives me 16, but that's not what we're doing. We're changing these to the same base, so powers of numbers. So 8 is going to be 2 to the third power because 2 times 2 times 2 is 8. And 16 is 2 to the fourth power because 2 times 2 times 2 times 2 is 16. Now your bases are going to cancel. 3 times x is 3x. 3 times 2 is negative 6. 4 times negative 1 is negative 4. From here, go through, solve your equation. For this particular problem, you should get 2/3. Number 6. I see a 25 and I see 125. Again, look on your chart and see where do I see a 25 and 125. Or you might already know that this is going to be a 5 problem, but if not, here I see 25 and 125. 25 can be changed to 5 squared. 125 can be changed to 5 to the thirds. Now this chart clearly is not every number in the world. I only did bases 2 through 6. 7 may pop up, 8, 9, 10, 11. I just wanted to get you started with your chart. So for number 6, I could change 25 to 5 squared. And we can change 125 to 5 to the third. Our 5's cancel. 2 times 2x is 4x. And 3 times x is 3x. 3 times 2 is 6. ... Go through, solve your equation. You should get 6 for this problem. A couple more that we'll go through and do. I see 9 and 27, so I can change both of these to be a base of 3. 9 is 3 squared. 27 is 3 to the third power. Once you get the same base, your bases cancel. Make sure you do the distributive property. Otherwise, if you don't, you're going to get the incorrect answer. Number 7, you should get negative 10. Number 8, 36 and 216. If you go back and look on your chart, these can both be rewritten with a base of 6. So 36 is 6 squared, and 216 is 6 to the third power. Once you have the same base, your bases cancel. Go through, do the distributive property, and solve your equation. All right, dot, dot, dot. Opposite operations, where you do to one side, you do to the other side. This is 7. And last but not least, number 9. Step 1, get this out of fraction form by making it be a negative exponent. Now that it's out of fraction form, we can think about some different ways to set this problem up. Now, this problem has 2 different ways to approach it. You can approach this as a base 2 or a base 4 problem. Again, I can make this be a base of 2. I can make this be a base of 2. I can make it be a base of 4. I can make this be a base of 4. So if I go back on my chart here, I see 16 and 64. There's 16, there's 64. So maybe we want to do a 2 to the 4th and then 2 to the 6th. Also, however, if I come over here, I also can make them base 4. So maybe I want to do 4 squared, and then maybe I want to change 64 to 4 to the 3rd. It doesn't matter which one you do, they're going to give you the same answer. So if you want to make them be both base 4, fantastic. If you want to make them both be base 2, fantastic, because you're going to get the same answer. I'm going to make them be base 4. No particular reason. That's just the last number I was working with, so it's in my brain. So I'm going to change 64 to 4 to the negative 3rd power. Because 4 times 4 times 4 is 64. And bring this over. And I'm going to change 16 to 4 squared and keep my exponent. Now my bases are the same. Cancel, cancel. Negative 3x plus 6 equals 6x plus 2. Go through, solve your equation. You should get 4/9. All right, and this is solving exponential equations. Step 1, make your bases be the same. Step 2, cancel your bases and do the distributive property. And step 3, solve your equation like would do a regular equation.